It is my absolute pleasure to introduce our next speaker. Tarak Shah is a data scientist at the Human Rights Data Analysis Group, where he serves as project lead on US-based work while also providing support to investigations, including in Syria, Colombia, and Sri Lanka. Tarak has bachelor's degrees in mathematics and philosophy from the University of California at Berkeley, and an extra little side note of interest, especially to me, is that he is also working in collaboration with the Innocence Project in New Orleans. I'm so excited to introduce him, and I would just ask you all to warmly greet him as he tells us why we need math in the fight to defend human rights.
Thank you all. Can everybody hear me okay? Cool. I'm so excited to be here. If I screw up a little bit, it's because I prepared myself some notes beforehand, but due to some technical stuff, I won't see them. So we're gonna rely on my practice. I work at a place called Human Rights Data Analysis Group, or HRDAG for short. So I'll be calling it HRDAG throughout my talk. And I'm a data scientist there. And what HRDAG is we're a group of data scientists and statisticians who do statistics for human rights. That is, hello? Yo. We partner with human rights advocacy groups to identify questions that can be answered or arguments that can be strengthened through the use of quantitative analysis. And my goal for today is to kind of introduce you all to what that actually looks like. So before I started working here, I was like, that sounds neat. I'd love to do data science for human rights, but I didn't have any real idea of what is that? Like, what kind of data science? What are the types of problems that you run into? So my goal today, again, is to make sure that you all leave knowing some of what that looks like. And if you're an educator, maybe you'll see an idea for an example that you can use. Or if you're a student, maybe you'll see an interesting problem that you want to research further. So let's get started. One quick note before we really get into it is that I am going to zoom in on some fairly technical details at different points in this talk. And so before we kind of get into all of that, I want to kind of set some context for why we're doing this kind of work. And so I'm going to start with this. I'm going to start with a quote from my colleague, Dr. Patrick Ball, as soon as I figure out how to switch slides. Okay. I'm usually pretty good at computers. All right. So this is a quote from my colleague, Dr. Patrick Ball. I will not spend most of today reading to you from a slide, but this will be the one exception to that. And so he says, human rights stories tell about the worst events that anyone can experience. Taking responsibility for human rights information means assuming an obligation to the witness, to the families, and to the victim. We are morally obligated to do the best work that's technically possible so that the victim's story is heard and believed. To do otherwise disrespects the victim's suffering. So again, we're going to start going into some fairly technical details, but this is why we have this moral obligation to get things right. And as you will see, the fight for human rights, huge multidisciplinary endeavor. It involves all aspects of society. Data analysis is a very small part of that, but I think it's a very important part. And within that, we're going to be looking at specific details of data analyses. So a small part within a small part. We're kind of digging down into the footnotes. But again, this is the overarching reason that we're going so far into detail. And the other thing I want to say is that during the talk, I'm going to make some references to materials that you can look at to learn a little bit more about either the historical context of the problems I'm talking about or the technical tools that we're using. And I've collected them all and put them on this GitHub repo. So instead of trying to like take pictures of the links I put up, you can just go over there and find everything that I'm talking about. And I'll show this a few more times to remind you. All right, is everybody ready for the first example? Cool. Okay, so we're gonna start with the genocide trial in Guatemala of General Jose Efrain Rios Montt. This is a picture of the trial, and here's some folks who were working on some of the data processing that we'll be talking about today. So let's start with a little bit of historical context. So there was a 36-year-long civil war in Guatemala, and a particularly brutal and violent period during that brutal and violent war happened under the presidency of Jose Efrain Rios Montt between 1982 and 1983. During that time, the army conducted a number of massacres where they killed entire villages, and it was very ugly. Guatemalan prosecutors charged him with genocide in 2013, and that's where we come in. And so I'm going to ask you all to kind of put yourselves in the shoes of a data analyst as we go through what we're going to try to figure out. So the question that we were faced with here was, given the evidence available, were the patterns of violence in Ixil regions of Guatemala between 1982 and 1983 consistent with genocide, which is the targeted killing of a specific ethnic group. So in this case, it's the indigenous people of this part of Guatemala, and they're known as the Ixil or the Maya Ixil. And I highlighted a handful of terms as in this sentence here. So we're going to go through each one. So we talk about evidence being consistent with some claim. Data analysts are not responsible for proving things. That's like a much larger endeavor again that involves many different actors. But what we can do is, looking at the evidence, say whether it is or is not consistent with a certain hypothesis. And second, when we're talking about genocide, we're not just talking about killing, we're talking about targeted killing. So that's kind of the basis of the question that we're going to try to answer, is whether the evidence is consistent with the targeting of Ixil people. So let's formalize this idea of targeting. So we're going to like put it into some context where we can actually measure it. So here we just see, we call this in public health like the relative risk. And so what we do is just calculate the proportion of indigenous people during this time who were killed by the army, and the proportion of non-indigenous people during the same time who were killed by the army. And if we compare those two proportions, then that can give us some kind of metric for measuring the level of targeting during a certain time period, right? So far, so good. This all doesn't sound too complicated, right? It is a little bit of arithmetic, but it's not like math, you know? So let's kind of dig into these rates, these homicide rates. So they're made up of a numerator and a denominator. In terms of the size of the population, the denominator, there was an official census conducted in Guatemala in 1981, right before the study, right before the period that we're concerned with. And although it was actually a little bit more complicated than this in the actual trial, we're going to just assume for today that based on that, we do have the denominator for this question. And that's a picture of the 81 census. All right, so where does the numerator come from? How do we know how many people were killed by the army? In human rights, the most common way that we find these things out is through various small and large-scale data collection efforts by individual human rights organizations, as well as international justice bodies. And what this data looks like are lists of the names of people who were killed and the date that they were killed and some other information, like identifying information about them. And that's the case in this example too. So here is like a quick summary of the data that we found ourselves with. So we see that we have records from 4 different databases. And I hope you all don't mind. I'm gonna like pop out of this mode so I can remember what each of these acronyms stand for. Okay, so each of these, we always refer to like the databases by their acronyms as we work, because we have to say them a lot. But just to introduce these, the first one is the International Center for Human Rights Research in Guatemala. The second one is the Recovery of Historical Memory Project, which was a project of the Catholic Church. The third one is the Commission. And then finally, there was a National Reparations Program, which also collected data like this. And so these are the sources of data that we have to work with, again, to find out that numerator, how many people were killed by the army. Notice I say here a couple of things. One, different databases may record the exact same homicide, so these are overlapping sources of information. And also, we use like some statistics terms here, but the way that we refer to these kind of data is a convenience sample. And what I mean by that is it's neither a complete enumeration, nor is it a random or representative sample. So those are like, if you've taken like a intro stats class, you've probably heard of those two types of samples and know how to do that kind of analysis. In our case, we have a convenience sample that is data, kind of what it sounds like. This is not to kind of criticize the data collection efforts of any of these databases or organizations, but rather data collection in these contexts is incredibly difficult, and we have to work with what we're able to work with. But we also have to keep in mind that the data might not be representative. The reason I'm kind of focusing on that aspect is because remember we started out asking a question about comparison, the rate of killing for the indigenous population compared to the rate of killing for the non-indigenous population. Let's say we find a difference. How do we know that the difference that we find actually reflects a difference in the rate at which those two populations were being killed by the army, or whether those differences reflect differences in the rates at which different killings were documented in these four databases? Is that kind of distinction clear to everybody? So the way that we do that is through a family of statistical methods known as multiple systems estimation. In ecology, these are also called capture-recapture models. And what they do in short is allow you to use the patterns of overlaps among data across databases in order to estimate the number of incidents, in this case killings, that were not recorded in any of the databases that you have. So that sounds both like perfect for the problem we're facing, but also a little bit magical. So we're going to do like a very simplified version of multiple systems estimation to help you get some kind of intuition about why this might work, right? And so the simplification kind of we're going to set up, it looks like this. So N is in our case, the total number of homicides during this period. A and B are two different databases, which each record some proportion of all of the homicides N, but not all of them. And in addition, we have M, which is the intersection between these two databases. Those are homicides that were recorded in both database A and database B. And so given this setup, our job is to figure out what N is, what the size of the overall number of homicides. And so we're going to use a tiny bit of probability theory and algebra to do that, but it's like, I'll walk you through it. So those first two lines that we're looking at, they're just describing the probability of a homicide being recorded in database A and database B. So it's just the number of records in A divided by N, right? And the number of records in B divided by N. I apologize that sometimes I use the letters to refer to the databases, and other times I use them to refer to the number of records in the databases. Hopefully it's clear. Okay, so line 3, it says the probability of being in the intersection M is equal to the probability of being in database A and the probability of being in database B. And assuming that those two databases are independent, then we can describe that probability as the probability of A times the probability of B. So that's what's happening in line 3. Once we've done that, we're good. We just have to move our n's around and multiply by n, divide, and we come up at the end, in this case, with two databases and some pretty strong assumptions about where those databases came from. an estimate of the overall number of homicides, not just those that were recorded in A or B, but all of them, right? So that is supposed to give you some kind of intuition about why this method sort of works. So what did we find in this case? By the way, uh, I showed you a picture of the trial before, and now you know that you saw the exact same slide as the judges in the genocide trial also saw. And I think they found it, well, fairly convincing, as we'll talk about. So the findings were pretty stark. The headline one was that during this period, the rate at which people were killed by the army between 1982 and 1983 in these 3 regions of Guatemala was 8 times greater for the indigenous Ixil population than for the non-indigenous population. And so at the time, the court found this and all of the evidence that was presented convincing and ended up convicting Rios Montt of genocide. It was at the time the first former head of state who had been convicted of genocide by his own country's justice. So this was like a big deal for human rights. That particular conviction only held for 10 days. There was a technicality, there was going to be a retrial, and then he died during the lead up to the retrial. But maybe a more important outcome of this is that the fact of the genocide is now like a historically accepted fact throughout Guatemala. Like everybody understands that this was what happened. And one of the things that like will be a running theme throughout this is that's kind of a precondition for making sure things like that don't happen again, is this kind of agreement about what actually did happen. Okay. So very quickly, I said we made some strong assumptions when I introduced multiple systems estimation. So in fact, like if you dig in a little bit, exactly how we presented it is not quite going to work. And we're not going to go super into detail today about how the models actually look, but I want to point out the different places where we made strong assumptions, because then I'm going to point you all towards some resources to read more. And most of those resources will be addressing one of these issues. So first off, we made this assumption before of homogeneous observation probabilities, or in ecology, these are called homogeneous capture probabilities. That is, we made the assumption that every homicide that's recorded in database A had an equal probability of being recorded. And the same thing about database B. So in fact, most of the time, that is not what human rights data looks like for a variety of reasons. You can imagine that if one of your sources of data is newspaper stories, that killing of a wealthy or famous person or a politician or a lawyer who lives in a big city is going to be more likely to be covered than the killing of a poor person in a rural area, for example. And this is fairly common across databases. So we know that we have to address that. We need to weaken that assumption in order to have some more confidence in what we're saying. Secondly, we made this assumption that the databases themselves, that recording in one database is independent of recording in another database. This too turns out to often not be the case with the type of data that we're working with. We sometimes have lists that partially subsume other lists because of efforts by those organizations to expand their own databases. We also have cases where people feel more comfortable reporting to one versus the other based on their own history with different organizations. But in general, this is our second kind of strong assumption that we need to kind of address. And so with that as kind of your guide and an introduction, I will remind you to go here to find all of the additional information, both about these methods and about the historical context in which they were applied. And now we're going to move on to example 2. And our second example is work that happened fairly recently in Colombia, and it was work on the work with the Truth Commission and the Special Jurisdiction for Peace, or the HEP. And there's some of the folks on the data analysis team who did some of the work that we're going to be talking about today. So let's go over some historical context. Once again, there had been decades of civil conflict in Colombia. And one of the outcomes of a peace agreement that happened in 2016 was the creation of a truth commission, whose goal was to kind of elucidate exactly what happened, who did what to whom. With the one of their kind of stated goals was non-repetition. So this was considered like an important part of making sure this doesn't happen again. And so the work that we'll be talking about was work that was conducted between 2020 and 2022 on this project. So what kind of data were we looking at? So this is kind of, we're going to kind of set ourselves up similar to the first case study where we want to count the number of people who were killed, and then additionally, like we want to kind of separate it out by who the perpetrators were and so on and so forth. But to start, this is what things look like when we first encounter the data. So we have nearly 13 million records across a large number of different databases. Many records refer to the same victim, although they may look different in one database versus another, either because of misspellings or because of different versions of people's names or misrecordings and so on. And importantly, there is no kind of unique identifier used across these databases. It's not like every single name is associated with some national ID number that we can just kind of join across. So why is this important? I'm going to ask you all to like go backwards in time to about 10 minutes ago when we looked at this slide. And I said very cavalierly in bullet 1 there that we know the size of M. How do we know how many people are in the intersection of two databases if there's no identifiers that we can, right? So that's kind of what we're going to be talking about for example number 2, is this idea of database deduplication. That is, given some large database, perhaps merged from multiple smaller databases, how do we know which records refer to the same person? So we often, vocabulary thing, we call these co-referent records if they refer to the same person. And we're not going to talk about the entire process, so I'm just going to hint at it, which is that we use pairwise classification and clustering. And the goal is to divide this larger database up into smaller clusters of records that are all co-referent. And then it's the number of clusters, basically. That's the number of unique people who are mentioned in this database. Okay, so that I already told you the answer. So what's the challenge? And the challenge comes with step 1, which is the pairwise classification step. So if you think about it a little bit, you can't really calculate the pairwise distances between every single pair of records in our database. Remember, we started with nearly 13 million records. So the number of possible pairs in a database with n records is n choose 2, which n times n minus 1 over 2, roughly n squared. 13 million squared is going to be too many for us. We would never have finished, and we would have just like burned a lot of fuel waiting for our computers to do something. So we can't deal with that. So we need to be able to somehow do this deduplication without comparing every possible pair of records. The way that we do this looks a little bit like this. And so instead of comparing every possible pair of records throughout the entire database, we chunk up the database into different smaller pieces where we hope within these chunks, most of the co-referent pairs are occurring. And then we just do pairwise comparisons within each of these chunks. So you notice this first chunk I made, it only has 4 records in it. So in this case, I designed all my chunks based on records that have the same last name. So that's, we call that a blocking rule because it's a rule that results in these block of records. In this case, I have a block of 4 records, and that leads to just 6 comparisons. That's going to be a lot better than whatever 17 times 16 over 2 is. Right, so that's what we mean by reducing the number of comparisons. Now, in practice, with the large databases that we're working with and with the type of data that we're talking about, we don't try to identify blocking rules that are as simple as the ones shown up here. Instead, what we do is we combine different fields. So maybe it's something like last name plus birth year or something like that, right? And so we call those conjunctions. And that is kind of the unit that we use for these blocking rules. So an example of a rule might be all of the records that have the same name and the same date. Or for example, the same last 5 characters of the name and the same county and the same year and month of the date, right? These are different examples. And in practice, we collect up a bunch of these different conjunctions with the goal that within the resulting blocks are most, if not all, of the co-referent records. And we've kind of carved out any pairs of records that are not co-referent to kind of reduce the amount of work that we're doing. Unfortunately, in our case, or fortunately really, but the thing that makes this difficult is we start out in our data with like 86 different columns. And you saw some examples of why there might be so many. So it's not just the name, it might be first name, last name, a few characters of the first name, all of these different ways. Because again, these data are collected in like a variety of different circumstances. And it's pretty unlikely, given kind of the scope of time and space across which these data were collected, that the same person will be recorded character for character in the exact same way in 2 different databases. There will always, or very frequently, be some kind of variation. So we build out 86 different columns that help us kind of like block the records into different groups of records. But now we started out with like a combinatorial problem where the pairs of records were too many. And now we have this problem. I don't know how to do the calculation, but like there's a lot of possible conjunctions when we have 86 columns, right? So how are we going to search for it? So anytime in our field, in the field of data science, when we run into a problem and we're not sure what to do, we collect some training data. And so that's what we did here. And so the thing that we're trying to understand is, what do pairs of co-referent records look like in the database? Do they often have similar features? Which features are more similar? Which features vary more? Stuff like that. And through a procedure that I won't go into super great detail about, we were able to manually identify through human review over 1 million co-referent pairs of records. So we have over 1.1 million pairs of records as our examples of what co-referent records look like. One other note here, which may or may not have been clear when I introduced this problem, is that given the number of records in a block of records, we're able to fairly efficiently calculate the number of overall pairs that would result in. We saw the formula, n times n minus 1 over 2. So we can do fairly quickly and repeatedly. And also, we're able to fairly quickly calculate the number of known co-referent pairs that are covered by any given rule. So when I say covered, I mean that both elements of that pair appear in a block together. That means they will be included kind of in our overall kind of set of candidates that we think are possibly co-referent. So given that, that allows us to kind of search through different conjunctions and calculate how many pairs they would generate and how many known true co-referent pairs they would cover in order to search for the best one. So that's kind of what we're going to do. And in this case, the approach that we ended up using called local search, it's kind of a modified version, but basically it's a local search, which is kind of a heuristic method. And so the setup for this is we decided ahead of time how many pairs we're willing to generate and do pairwise comparisons. This is based on like the size of our server and the amount of time we had available and so on. And then we set a goal for ourselves. We have these 1.1 million known co-referent pairs. And so our goal is like, let's try to make blocks that together generate less than 250 million total pairs, but also cover as much of those 1.1 million known ones that we know. And the local search method that we use here is to build up our conjunctions bit by bit. At each point, searching for the most promising next conjunct to add to our conjunction until we reach some stopping criteria. So that's the overall setup. And it worked. the way that ran, we were able to do it in 1.5 hours, which was like much better than the millions of years that we were facing before. We were able to cover 99.8% of the known pairs. So, based on the best information we had, this is doing a decent job. And altogether, we're only generating under 100 million pairs to start. So remember, we talked about, I forget the number, but something in the trillions of the total possible that there could be. So we've dramatically reduced the size of the problem. And there's the results. And once again, this is a very tiny part of a very large data analysis. So the technical appendix to the Truth Commission's report, I think, was something like 600 pages. And that data analysis itself is a fairly relatively small detail in a much larger effort that was the Truth Commission's report. But overall, that entire effort, again, kind of bringing us back to why we spend so much time trying to solve such specific problems. And I would want to kind of point out the very end of this: without reconciliation, the risk of repetition remains real. So this is kind of why we're working so hard on this. Okay. All right. I'm going to move on to the third example now. And before I do that, way more details about blocking, as well as the Truth Commission and links to the Truth Commission's report are all, you can find them there. All right, our third example takes us to Chicago. And sorry, I just realized that the titles are a little bit obscured. So this says investigating state violence against Black women and girls. And once again, here's some of the folks who worked on the project that we're about to talk about. So in order to understand the historical context of this third example, we're going to go back in time a little bit to 2005, to the story of Diane Bond, who is a resident of a housing complex of Chicago, and she lived at this time in a housing complex known as Stateway Gardens. And while she was there, over the course of several days, she and her son were attacked and assaulted both within their home and outside of their home by a crew of police officers who were collectively known as the Skullcap Crew. These are members of the Chicago PD who were especially violent and abusive of residents of this part of Chicago, which the name might suggest. Like normally, groups of police officers aren't supposed to have scary gang names. So that's usually a sign that something's off. Right. So Diane Bond, she, in response to what had happened to her, filed a complaint, and then that became eventually became a federal civil rights lawsuit known as Bond v. Utreris. And one of the things that was important about that process when she did it was that she did not only, in the civil rights lawsuit, she did not only name the officers who had assaulted her and her son. She also named the police commissioner and the city of Chicago itself. And the reason she did is because, again, as you might know by the name, the Skullcap Crew, this crew of officers had a history of doing this kind of thing. And yet they had never been disciplined. And so her claim was that the responsibility goes much higher than just the people who did this to her, because there were people who could have stopped them who didn't. And so why that's so important for us is because those higher level entities were named in this lawsuit. Through legal discovery, she was able to request data about police misconduct, allegations of misconduct against Chicago PD officers. So this comes in a variety of ways, either through internal affairs investigations, or there have been a series of different independent oversight commissions in Chicago over the years where people can make complaints against police. Before this case, that data, despite the fact that that data was being collected, it was not public. So nobody was able to see it, and hence this case. And that case and another one known as Calvin v. Chicago resulted collectively in the courts in 2014, making misconduct data, the Chicago PD misconduct data, public information. This was the first time in Chicago that this was true. This was a huge step, not only for Chicago, but for human rights in general. And one of the outcomes of that release was the development of CPDP. So here you're looking at the pictures, screenshots from a website known as cpdp.co, which stands for the Citizens Police Data Project. And that's a website run by our partners at the Invisible Institute, who did a lot of the work that we're talking about today. On the left, you kind of see the landing page, and you can look up allegations of misconduct, both by officer name, as well as by date, and CR number, and so forth. And when you look at CR being complaint register, and when you look up these records in the database, you see something kind of like what you see on the right-hand side, a bit of structured information about the complaint. And so this is huge. Like I said, it led to lots of reporting. It led to some officers getting disciplined for the first time, and so on. But I kind of want us to think a little bit about how this record comes to be. So what are the series of steps that occur in order for a record like this to go into a database? So in practice, somebody experiences some kind of violence, and they make an effort either online or in an office to go and report their experience in the hopes that there may be some kind of consequence or something. That story, so they show up and they tell a story, they explain what happened to them. That all gets kind of summarized down into a handful of kind of like coded variables, right? So black, female. Up there we see illegal search, improper search of person, right? So that entire story that was told gets like collapsed down to this thing which they call in the database the primary category. And so our partners at the Invisible Institute were relying on CPDP in conjunction with interviews and other reporting that they were doing in this study of gender-based violence that at the hands of Chicago police. And I'm gonna flip over to the next slide. It is a little bit violent and graphic, so if you don't want to, I will describe without reading what is up there, but it's a bit of text. And what it is the actual summary description of the allegation that resulted in this coding of illegal search, improper search of person. And so on the right, hopefully, if you want to, you're able to read it. You're able to see the allegations, kind of summary description of the allegations that became that complaint. And what you're able to see there is that this violence was sexual in nature, and very much was a part of this investigation that our partners at the Invisible Institute were working on. And yet, if all they were relying on was the primary category, they never would have been able to find this record. And they were finding a number of records like this that all had some kind of different coding other than sexual violation or something. So this idea of collapsing a record, of collapsing a story down into a primary category had the effect a little bit of covering up certain kinds of violence. And so this, for us, is like a form of impunity. This story does not kind of enter in to a type of problem that's shared. And this is just one example, but what they were finding was that this pattern was occurring a lot, that there is kind of the primary category, but underneath the primary category, if you did a FOIA request, that's Freedom of Information Act request for the investigative documents, they were finding a number of pieces of the story that had been lost by the time it kind of got into the primary category stage. So this was important. At the time, though, we were a little bit stuck. You can do individual FOIA requests for those investigative documents, but there are tens of thousands of complaints every year, and we didn't know which ones had the stuff beneath the surface. Then there was a breakthrough in 2020, and in order to understand the breakthrough, you have to understand the story of Charles Green, who Charles Green was wrongfully convicted and incarcerated at the age of 16 and spent over 20 years in prison for a crime he did not commit, and he because of a coerced confession, again, when he was 16. And so he was released from prison in 2009, but has continued to fight for both his innocence to fully expunge those records. And part of his claim, again, because of the way that he ended up where he ended up, was that in order for people who have been accused of a crime in Chicago to be able to mount a proper defense, they need access to the full misconduct data about the police who arrested them. Again, because some of them may do things like coerce confessions out of teenagers. So he's been fighting in court for access to these records, not just the ones that we see on CPDP, but the full investigative documents behind them. That fight had a weird thing happen in 2020 when the city of Chicago, for unknown reasons, missed a court filing deadline. And because they missed the court filing deadline, the judge made the investigative documents between the years of 2011 and 2015 public kind of by default. So he's been fighting for access to records going back to 1967. We don't have that right now, but what we do have access to is the full investigative documents for misconduct complaints between 2011 and 2015. So this seems like it's going to be a real help to this investigation that I introduced this with, because now we can see beneath the surface. Unfortunately, what we have at that point is hundreds of thousands of pages of scanned documents. And the information that we're interested in is inside those scanned documents, but it's in unstructured narrative text. So how exactly do you go through searching for these incidents? They may be described in a number of ways. Maybe you can think of certain keywords that you want to look for, but it gets very complicated very fast. So once again, when we don't know what to do, we collect some training data. And in this case, we organized small reading groups to start. These were 8 readers at the beginning, groups of 4 who each met once a week on Tuesdays and Thursdays. And we would randomly sample from the documents that we had and have them read it. And they would take notes, and eventually they started doing a structured annotation. And all of these readers are residents of Chicago who have had kind of like firsthand experience of some of these types of violations. So they were drawn to this work to begin with, but also had a special expertise about these types of violations. So those initial reading groups, one of the outcomes of the work that they did was what we call the annotation dictionary. They came up with a set of like structured selectors that are themes that occur in these documents that are hidden in some way by the primary categorization. And eventually, after kind of formalizing our annotation dictionary and presenting some of our work that we were doing to the community, we asked people if they would be willing to read and code additional documents to use as kind of additional evidence or training data. And we ended up being very successful in that call, and over 200 people signed up and came and got trained and started reading, and over the course of several weeks, read and annotated 4,000 documents. And here are some examples of the types of selectors. Again, we use this term selectors because we're going to use it to select records from a database that they were identifying. So we've talked about sexual violations, home invasions when an officer enters somebody's home without them wanting them to, domestic violence and stalking. This was surprisingly frequent in the data that we were finding. This is cases where the officer has some kind of personal or historical relationship with the person who they are targeting. Policing of parents and children, targeting of people based on their gender or sexuality, and neglect, and different versions of neglect that they were identifying. And the thing that these examples that I have up on the screen kind of have in common is that they are, in general, the types of violations that are underdocumented throughout human rights. And additionally, they are, in our case, the types of violations that are made invisible by the primary categorization system. So they might get categorized in some other way than one of these categories. And finally, they disproportionately impact women and gender nonconforming people. So these became, and a couple of others, but these became kind of the types of things that we were searching for and the types of things that those volunteers were reading and annotating documents for. And again, they collected over 4,000 examples. Then with that data, we did this, which maybe I will walk you through, but it wasn't my idea to call it Judy, but it did get called Judy. So the basic idea is we trained a machine learning model using the 4,000 records that we had collected as training data. And then we kind of created features from the raw text that we had gotten from the scanned documents using an unsupervised technique, topic modeling. And so here we have features and here we have labels. And so that is kind of what you need in order to train a machine learning system. And so with that, we were able to classify different complaints based on these categories. And this gave us like new tools because in addition to the primary category and the other structured information that existed prior to this, we now have these additional fields and we're able to label an individual complaint using more than one category too. So something could be both a home invasion and a sexual violation, for example, right? Which was not possible using the former primary categories system. And in this this work has led to a bunch of different stuff, mostly like reporting and some pushes to for specific items of reform that have been pushed at City Council. You can read more about some of those outcomes at btsurface.com. One of the things that I wanted to highlight, or one of the kinds of examples of the types of results that came out of that work that I want to talk about a little bit was going back to this idea of neglect that I introduced earlier, and in particular, neglect following a sexual assault. So that is somebody has experienced a sexual assault and tries to report it to the police, and then the police refuse to open an investigation. They blame the victim, or they otherwise somehow mistreat the person who came in. And what we found again between 2011 and 2015 using these tools, we were able to identify and verify, like read and make sure that at least 90 instances of this kind of neglect following a sexual assault, including 24 where the survivor was a minor. And I want to tell that story a little bit partially because that's the type of information that was getting completely covered up by the old system. But also like to think again about the process by which these records come to exist. So you have to kind of like step through the types of experience that occur leading up to one of these complaint records, which is the very first part is a very traumatic event, which is experiencing sexual assault. Then after that, and we know from surveys that many people don't try to report those assaults to police at all. Of those people who did, so those who were mistreated or otherwise used by the police when they tried to report, then had to come back to another agency in order to report that mistreatment. So you think about all of the people who had a similar experience who did not report. We're talking about 90 cases over 5 years. So this is like 1 or 2 people who report per month. This is not counting all of those people who chose not to report. And the reason I point that out is because one of the things we found when we started reporting, started sharing these findings with community members is we talked to people who saw their own experiences reflected in the data in the narratives that we were sharing, despite the fact that they themselves had not actually filed a complaint. And again, this is important because like one of the ways that these types of crimes can affect people is through feelings of isolation. That is feeling like you are alone or that something happened to you and nobody else. And so what people were finding here was that in fact, they had a shared experience with hundreds of other people in the city. And that again becomes the beginning to that like is the core for how people are able to come together to try to think about how to address sexual violence in their communities in a way that is healthier than what we have currently. Right? But it all starts with understanding that you are not alone. I think I'm going to stop there. Anyways, if you want to read more about that, btsurface.com. And again, I will remind you that if you go to that GitHub link, you can find way more resources about the projects we talked about today, as well as about some of the technical methods that we're talking about. That's my email address. So if you feel like you want to email me, you can. I think that's all I really have to say. But for questions.